Life's building blocks found in space. A breakthrough discovery. Imagine a universe where the building blocks of life are not scarce, but abundant and widespread. What if the very fabric of our cosmic existence is infused with the molecular ingredients necessary for life to emerge? This is the tantalizing prospect that scientists have stumbled upon, and it's about to revolutionize our understanding of the origins of life. But here's where it gets controversial. The discovery of complex organic molecules in a planet-forming disk suggests that life's chemical precursors might be more common than we thought, sparking a heated debate about the likelihood of life existing elsewhere in the universe. In a groundbreaking study, researchers have tentatively detected ethylene glycol and glycolinitrile, molecules linked to DNA and amino acids in a protoplanetary disk around the star V883 Orionis. This finding has significant implications for our understanding of how life arises. And it's leaving many to wonder, are we alone in the universe? The discovery was made possible by a rare stellar outburst that heated up the surrounding disk, causing frozen molecules to evaporate into gas form, where they could be detected by powerful telescopes like the Atacama Large Millimeter Submillimeter Array, ALMA. The team, led by Abubakar Fadol from the Max Planck Institute for Astronomy, observed the system multiple times between late 2021 and late 2022. And their findings suggest that planets could form with life's chemical building blocks already in place. But what does this mean for the search for life in the universe? And this is the part most people miss. The discovery of these complex molecules in a planet-forming disk implies that the emergence of life might not require a rare sequence of favorable events, but rather it could be a natural outcome of the chemical environment in which planets are born. The research team emphasizes that these are tentative detections that still need confirmation, but the implications are profound. If planet-forming disks routinely develop complex organic molecules, then many planets may begin their existence already containing the molecular ingredients necessary for life to emerge. As we continue to explore the universe and discover its thousands of new planets each year, the question remains, are we on the cusp of finding life beyond Earth? The answer, much like the universe itself, remains vast and mysterious. But one thing is certain. The search for life is about to get a whole lot more interesting. So, what do you think? Do you believe that life's chemical precursors are abundant in the universe? Or is this just a rare anomaly? Share your thoughts in the comments below, and let's continue the conversation. The discovery of complex organic molecules in a planet-forming disk is a game changer, and it's about to spark a new wave of research and debate in the scientific community. Stay tuned, folks. This is just the beginning of an exciting new chapter in the search for life beyond Earth. Are the seeds of life assembled in space? A stunning discovery says it's possible. Imagine if the building blocks of life weren't created on Earth, but instead hitchhiked across the cosmos. This week, a groundbreaking discovery using the ALMA telescope revealed complex organic molecules like ethylene glycol and glycolinitrile that could be the cosmic seeds assembling life's ingredients before planets even form. Here's why this finding rewrites the rules about our universe's most fundamental questions. The space age of organic chemistry. For years, scientists debated whether prebiotic molecules formed locally on planetary surfaces or arrived via interstellar delivery. New evidence tips the scales toward the latter. In the swirling gas around the young protostar V883 Orionis, astronomers detected 17 types of complex organic molecules. These aren't just simple carbons. They include precursors to sugars and amino acids, which are molecular blueprints for life on Earth. But here's the controversial twist. Previous theories assumed violent stellar outbursts erase these molecules. Instead, the ALMA observations suggest they survive and thrive through cosmic upheavals. This directly challenges the long-held reset theory, where life's ingredients were thought to reinvent themselves repeatedly. As co-author Kemper Schwartz explained, it's like interstellar molecules are handing down inheritance to planetary systems. ice, radiation, and the galactic delivery service. In these young star systems, frozen organic compounds glom onto dust grains. When stars flare up, they heat these ices just enough to release trapped molecules, providing a cosmic delivery mechanism. Ethylene glycol, found here for the first time beyond our solar system, could form through UV radiation acting on more basic compounds, says Tushar Susaharia, leader of MPIA's Origins of Life Lab. Imagine this happening across galaxies, leaving molecular legacies for future planets. What this means for finding alien life. If these seeds form universally in stellar nurseries, basic biochemicals might be the cosmic default. Should we eventually detect glycine or adenine on exoplanets, this discovery suggests they're not signatures of life, but foundations birthed in space. However, the real bombshell lies in what's missing. Higher resolution telescopes may soon reveal even more intricate chemicals, pushing our understanding of how chemistry escalates toward biology. The million-dollar question. While the Duels team celebrates this breakthrough, they're already asking, what's hiding in the spectrum we can't yet decode? Telescopes like ALMA and its successors might soon chase down molecular fingerprints, shining light on how entropy becomes your DNA's raw material. Could this discovery mean life is more common than we thought, or that it's still a rare cosmic accident? The answer might be written in light from stellar distances. Crucial molecules discovered in planet-forming disk, a step towards understanding life. The discovery of life's building blocks in space is truly astonishing. Recent findings by astronomers have unveiled a remarkable treasure trove of 17 different complex organic molecules surrounding the protostar known as V883 Orionis. Among these discoveries lies the tentative detection of ethylene glycol and glycol nitrile, key precursors to essential life components like the amino acids glycine and alanine, as well as the nucleobase adenine, integral to DNA and RNA. It's important to clarify that while these findings do not confirm the existence of life, they do suggest that the foundational elements necessary for life may form throughout the cosmos when conditions are right. Complex organic molecules, often referred to as COMs, have been identified in various locations throughout the universe, including the massive molecular cloud where stars are born. However, the process of star formation is incredibly energetic, raising questions about whether these delicate molecules could endure the tumultuous protostar phase and subsequently integrate into the material that forms planets from the outset. A group of researchers, spearheaded by Abubakar Fadul from the esteemed Max Planck Institute for Astronomy, utilized the Atacama Large Millimeter Array, ALMA, to delve into the chemical makeup of V883 Orionis. Their current objective is to gather higher resolution data, to deepen our understanding of these findings, verify the tentative detections, and potentially uncover even more complex organic molecules. If these crucial molecules can exist in such harsh environments and survive the intense conditions of star formation, it offers compelling evidence that they might integrate into planets, ultimately creating a habitat conducive to the emergence of life. Abubakar Fadul expressed his enthusiasm, stating, "Finding these molecules in such an environment is really exciting, because this is the final phase after a star has formed, yet before the actual formation of planets begins." He further elaborated, "If these molecules can withstand the conditions present during star formation, it gives us a significant clue that they could eventually meld into planets, paving the way for the emergence of life in the future." Understand the origins of life, we must track the formation of the molecular building blocks essential for life on Earth. Previous research has uncovered organic precursors in interstellar space, within the comets' tails, and even in samples retrieved from asteroids. This indicates that space is home to fascinating chemistry, yet we still grapple with whether these molecules are continually generated or if they can endure the transformative cycles of planetary development. Fadul commented, "Given the ferocious conditions experienced during star formation, it's uncertain whether these molecules truly survive or if they emerge within the disk itself. Investigating where these molecules originate is among the enthralling questions we are eager to explore further." V883 Orionis is intriguing in its own right. It is approximately 1/3 more massive than our sun and significantly younger, at just around 500,000 years old.
By studying this and other protoplanetary disks, scientists hope to unlock the secrets of our own origins and the genesis of all life forms on Earth. The results of his groundbreaking work have been detailed across 3 papers published in prominent scientific journals, namely the Astrophysical Journal Letters, the Astronomical Journal, and the Astrophysical Journal itself. This raises a tantalizing question. How do these findings reshape our understanding of life's origins in the universe? Are we on the brink of uncovering the keys to the very building blocks of existence? Share your thoughts below. Do you agree with these findings, or do you see things differently?